let's work through the steps of finding all the real zeros of a polynomial function. For our example, we'll use f of x equals 3x cubed plus 4x squared minus 7x plus 2. First, we'll determine the maximum number of real zeros. To do that, we'll look at the degree of the polynomial function, or the highest exponent. And that is 3 here. So the maximum number of real zeros that we can have is 3. We may not have 3, but that's the most we can have. Second, we'll use Descartes' rule of signs to determine the number of positive real zeros we could have and the number of negative real zeros we could have. For positive real zeros, we'll look at the number of sign changes in the original function. So we go from positive 3 to positive 4, that's not a sign change. From positive 4 to negative 7, that's our first sign change. And from negative 7 to positive 2, that's our second sign change. So for positive real zeros, we could have 2 positive real zeros, or we could have 2 minus 2, or 0 positive real zeros. For negative real zeros, we need to substitute in negative x for x. So 3 times negative x raised to the third powers plus 4 times negative x squared minus 7 times negative x plus 2. Let's simplify that, and we get negative 3x cubed plus 4x squared plus 7x plus 2. And now we'll count the sign changes here. So we go from negative 3 to positive 4, that's our first sign change. We go from positive 4 to positive 7, there's no sign change. And from positive 7 to positive 2, there's no sign change. So for negative real zeros, we'll have 1. Okay, third, we'll find the possible rational zeros, or possible rational roots. So we need to find the factors of p, or the constants. Our constant was 2, so the factors of 2 are positive or negative 1 and positive or negative 2. Q will be the factors of our leading coefficient, which was 3. The factors of 3 are positive or negative 1 and positive or negative 3. And then we need to find all the different combinations of p over q. So we have plus or minus 1 over 1, which is plus or minus 1, plus or minus 1 over 3, which is plus or minus 1/3, plus or minus 1 over plus or minus 2 over plus or minus 1, which is plus or minus 2, and then plus or minus 2 over plus or minus 3, which is plus or minus 2/3. So these are our possible rational roots, our possible rational zeros. Okay, so then we will use synthetic division, or you could use polynomial long division or substitution to go through these possible rational roots to see if any of them do work and are actual zeros. So we're testing them. I'm going to use synthetic division, so I'll set up synthetic division using the coefficients 3, 4, negative 7, and 2. I drew in my remainder box. Remember, we will be looking for a remainder of 0. This is where we'll put our 0, and I know that my first coefficient will always come down, so I'm drawing the 3 down. To save us time in the video, I know the only one of the possible rational roots that works. Otherwise, this is we have to go through trial and error to find if any of them work. I know that 2/3 works. 2/3 times 3 is 2, and then 4 plus 2 is 6. 2/3 times 6 is 4. Negative 7 plus 4 is negative 3. 2/3 times negative 3 is negative 2. And then 2 plus negative 2 gives us our 0. So 2/3 is a 0. So we found our first 0, 2/3. Now let's look at our quotient here. Remember, the negative 3 represents our constant, the 6 is the coefficient of our linear term, and the 3 is the coefficient of our quadratic term. So here we have the polynomial 3x squared plus 6x minus 3, and we can set that equal to 0. can actually factor out a 3 since it's a common factor. So I have 3 parentheses x squared plus 2x minus 1 equals 0. So we'll look at further factoring what's in parentheses, the x squared plus 2x minus 1. So our next step, once we have a quadratic term, then we will use factoring or the quadratic formula. Technically, you could also use completing the square to find the remaining zeros. Now, x squared plus 2x minus 1 does not factor. So I'm just writing it up here so you can remember what we have. We also had 2/3 as our 0. We are going to use the quadratic formula since x squared plus 2x minus 1 does not factor. A will equal 1, b equals 2, c equals -1. Substituting in, we have x equals the opposite of 2 plus or minus the square root of 2 squared minus 4 times 1 times -1 all over 2 times 1. Simplifying, we get -2 plus or minus the square root of 4 plus 4 all over 2, or -2 plus or minus the square root of 8 all over 2. Let's simplify the square root of 8. Remember, we can write that as the square root of 4 times the square root of 2. The square root of 4 is 2, so we can write this as 2 radical 2, and I'll substitute that back in to where we're simplifying from the quadratic formula. So we have -2 plus or minus 2 radical 2 over 2. To continue simplifying, I'll break this into 2 fractions. So I have -2 over 2 plus or minus 2 radical 2 over 2. And now we can see that the 2's cancel, and we're left with -1 plus or minus the square root of 2. And those are our 2 other zeros. So they're irrational. So I have -1 plus radical 2 and -1 minus radical 2. You can see I have 2 positive real zeros, and I have a negative real zero. But I have 3 real zeros. Now, sometimes you may be asked to actually factor the polynomial. Remember, factors are built by doing x, or whichever variable we're using, minus a 0. So we could write our f of x as x minus 2/3 times x minus, in parentheses, -1 plus square root of 2, and then in parentheses x minus, in parentheses, -1 minus the square root of 2. And then we can't forget about the 3 that we factored out up here. So that 3 comes out in front. So this is factored. It could be simplified a little bit. Like I could distribute this 3. So 3x minus 2, this is still a linear factor. And we could get rid of those inside parentheses in my other 2 linear factors. We could distribute the negative. So I have x plus 1 minus the square root of 2 and x plus 1 plus the square root of 2. So I have 3 linear factors. Or if we're not asked specifically for linear factors, I could have my 3x minus 2, and then we could go back to that x squared plus 2x minus 1 that we used for the quadratic formula, which is what we would get if we multiplied out my x plus 1 minus the square root of 2 times x plus 1 plus the square root of 2. So all of those are variations of what it looks like factored.